Hello everyone, my name is Vishwesh Joshi. My ID is 24CS031 and I am from CSE CSPIT. Today, I am going to demonstrate the graphics pipeline, which is a fundamental concept in computer organization and architecture. The graphic pipeline is used by graphics processing unit to convert 3D objects into 2D images that we see on the screen. In this animation, I will explain how a simple triangle is processed step by step through different stages of GPU pipeline. Let's begin with the input stage. Here we have a simple triangle made of three vertices. Each vertex contains 3D coordinate values which define its position in the space. In this stage, the triangle is just raw data. It does not have any colors, lighting, and visual appearance. This raw geometric data is passed into first stage through the pipeline like this. Now, the triangle enters the vertex shader stage. In this stage, each vertex is processed individually. The main operation performed here are translation, rotation, scaling, and projection into screen. As we observe in the animation, the triangle moves and transforms like this. However, the shape remains unchanged. This is because the vertex shader only modifies the position of the vertices and does not create new geometry. This stage determines how the object is positioned related to the viewer. Next, we move to the geometric shader stage. This stage works on entire primitive, which is, in this case, a triangle. Unlike the vertex shader, the geometric shader can modify triangle, duplicate it, or generate new shapes. In this animation, we can see that the triangle is flipped or duplicated. This demonstrates how geometric shader can dynamically alter geometry. However, this stage is optional and may not be used in all applications. After geometric processing, the triangle enters rasterization stage. In this stage, the triangle is converted into grids of small unit and pixels of many square shaped elements. As shown in the animation, the triangle is broken into many small square-shaped elements. This step converts geometric shapes into formats suitable for pixel-level processing. Next, in the fragment shader stage, here each element or fragment or pixel is processed to determine its final color. This includes applying color, lighting calculation, and texture mapping. In this animation, we can gradually see that grading that the pixels grading color are gaining. This stage is responsible for giving the final visual appearance to the object. Finally, we have reached to the final output stage, also known as the frame buffer. At this stage, all the pixels are combined to form final image. As we can observe, the pixels now form a complete colored triangle displayed on the final screen. This is the final render output seen by a user. One of the important advancements in modern graphics system is the concept of programmable pipeline. Earlier, GPUs used a fixed pipeline, but modern GPUs allow developers to write custom shader programs. This shader provide control over transformation, lighting, and visual effects. Additionally, GPU perform this operation in parallel, making them extremely fast. This is why GPUs are widely used in gaming, simulation, virtual reality, and artificial intelligence. To conclude, the graphics pipeline transforms a simple 3D object into fully rendered 2D image through multiple stages. Each stage plays an important role in generating the final output. This 3D animation helps in understanding the internal working of GPU in the clear and visual manner. We, we will now see a full and complete animation for our GPU. Okay, so thank you for listening.